Bonjour à tous. Déjà, bravo, vous avez choisi la meilleure salle. Je crois que je vais faire cette blague toute la journée. Bienvenue pour cette première conf de Mobilis Immobilier en présentiel. Donc vous êtes dans la salle Jules Verne et je vais vous accompagner toute la journée. Vous avez peut-être changé, je vous en voudrais pas, mais tant que vous revenez. Donc je m'appelle Marion Valentin, si jamais ça peut vous servir. Alors, comme ça va être la meilleure salle, ça va être la salle de l'ambiance. Donc, on va accueillir les speakers en les applaudissant pour donner un petit coup de boost. Trop bien. Parfait. Je reprends mes notes parce que j'ai pas tout appris par cœur. Notre premier speaker n'est pas nantais, mais il est bordelais. Il est autant passionné par le volet que par le développement mobile et surtout l'univers Android. Android. C'est bon. Et aujourd'hui, il vient nous partager son avis et les usages qu'il a de Jetpack Compose. Vous pouvez accueillir, comme on s'est entraîné tout à l'heure, Vincent Auguin.
Thank you, Marion. Good morning, everyone, and welcome to this presentation. So, since Jetpack Compose became a beta early 2021, I had the chance and the opportunity to build multiple applications full Compose. Since then, Jetpack Compose has gained massive popularity, and today I want to share with you essential guidelines to scale your code with Compose. So also please note that this presentation is kind of platform agnostic, because what will be exposed here can also be applied to Kotlin multi-platform desktop and iOS, and it's not strictly for Android, despite the title. So who is speaking to you? So Marion said it, my name is Vincent Auguin, I'm an Android developer. I recently joined the company MWM, standing for Made with Madness. We are the top French app publisher, and we are building creativity-oriented apps powered by AI. Quick words about me. Quite a rare thing in our era, but I don't like coffee, so don't judge me, please. I don't like daily meetings before 9:30 in the mornings, and however, I love the product-minded engineer approach, so I encourage you to Google that if you don't know it. And I never say no to a sport or game boards nights with beer. You can find me on LinkedIn /Vincent Auguin. So for this presentation, I will focus on three main topics: the cognitivity, the responsibility, and the optimization of Jetpack Compose. So small disclaimer here. This is a presentation that aims to an audience that is already kind of familiar with Jetpack Compose. So I will not recap what is Jetpack Compose, how it works, why you should use it, etc. So it's more for an intermediate level. So cognitivity. So basically, it means that this is the way of factoring your code to help other contributors to better analyze and maintain your code base. Let's start with a foundation principle of a declarative UI framework like Compose, the atomic design. So you maybe already heard of it, but the atomic design aims to slice your composable and tells you how you should logically slice them. So the ideal pattern is a page built upon a template made of organisms, an organism made of molecules, molecules made of atoms. So what is an atom? An atom is defining a single layout, and a layout is the leaf of Jetpack Compose. So when your Compose tree is fully resolved, the leaves of your tree are necessarily a layout. So hopefully Compose came with atoms that we daily use, such as the box, the column, the row, and the canvas. A molecule is created with multiple atoms, and if you are using a design system like Material, then Material will provide most of molecules, such as a surface, a button, a text, an image, etc. The organisms are made of molecules and atoms, and this is generally at this point that us developer, we will code our composables. And we will code composable that fits specific needs for our app, such as a header, an avatar page, a sign-in button, or whatever you need. A page or a screen, sometimes called a screen, is the aggregation of what the user is seeing on its whole screen at a given time. So it can be made of organisms, molecules, and atoms. And for instance, we will have some top-level composable like home page, profile page, settings page, etc. By the way, you can create a template to build your page upon it. And this is generally the case when you are creating, for example, a payment funnel or an onboarding funnel, and all the pages are kind of similar, share the same structure, and you want to reuse the page, then you will call, for example, your page template. Okay, another principle to improve your code cognitivity is the never nesting principle. So it means that you should never nest more than 3 levels of depth in your code statements. So let's see an example. So when your brain is first reading this function, it has to compute a lot of branch condition, and it can be hard to follow and to understand. So here we have a composable header, which have up to 5 levels of nestings. And here at this when statement here, we don't want to nest anymore to reduce the cognitivity. So what we want to do is to declare new composables and wrap them to reduce the nesting. So here I create 2 composables, avatar and sign-in button, and magically this function becomes much more readable. And by the way, this is a very good practice in programming, generally speaking, but I found it even more vital in Compose to scale your code. Plus, it fits with atomic design principle. Next topic, the state and the events. So when you are creating a page, a template, or an organism, you can wrap your inputs of your composable, the parameters of the functions, inside the UI state and the UI event. So it will help you to reduce the number of inputs and identify quicker what parameters is related to your business logic. So let's see an example here. Here I want to define a homepage UI state that defines 3 properties that I will use to construct my view: username, mode, and show ads. Also, I want to define a data class homepage UI events that declare 2 high-order functions returning void. So this function will help me to forward the interactions that the user perform on the view. Now I can declare my composable homepage with only 2 parameters, the state and the events. And it is helping me and my brain to not confuse with too much parameter and inputs to read. So this is also a good practice because if you want to add or remove a parameter in the state, let's say, you will not have to change the prototype of the function and then modify all the places where homepage is declared in your code. You just have to modify the instantiation of homepage UI state, so it's much more scalable. Next up is responsibility. Sorry. So what's to understand here is what is the responsibility, the scope of responsibility my composable should own and should have. The boundaries. So the answer is as minimum as needed. Meaning that we prefer to use a stateless approach to let the parent composable to provide the state. And we define a state that is then immutable, that will not change, because if it changes, it will steal the responsibility of the parent, because if it changes internally, the composable will maybe change bypassing the parent. So we don't want that, that's why it should be immutable. And similarly, we don't want our events to return something, so the lambdas will not return something, because we don't want our composable to react because of the type of the value that has been returned. Otherwise, it can bypass the state that is passed down to the composable. So we are in a unidirectional loop. The state is always passed down to the composable, and the events are always triggering up by interactions and never return something. So for instance, we can imagine a photo picker composable which takes in two parameters: the state, the selection, that is a list of items selected, and a callback that is triggered when the item selection change. For example, with an ID that is tracking the concerned item that has changed, and also a boolean to flag if it's selected or not. Here we can see that this is the parent composable, the one who will instantiate photopicker, who will call photopicker, that is responsible to pass the actual snapshot of the selection and also update as necessary the selection. So by the way, you can see that here I don't use UI state or UI event, but it's purely because I'm in a presentation and I don't want to lose too much space, so it's only for demo purpose. And you will tell me, okay, but at some point in the hierarchy, there must be a composable that holds a state. Otherwise, it is an infinite cascade. And yes, you are right. There is a parent composable at some point that is taking the responsibility to store and to update this state. And that's when the view model enters. So here we have a stateful composable, generally high level, that will get a view model and declare its children that are stateless, and pass to these stateless composables the UI state provided by the view model, and also fast forward the interactions to the view model, to the appropriate function of the view model. So let's take a look at this high-level composable. What we can see here, that is the first step is getting the view model, here home view model, sorry. And the second step is getting the state, the UI state provided by the view model. So here I collect it on a state flow. So each time the view model push or emit a new value, the newest value of the state, then this magic collect as state function will automatically update my variable state. That is immutable. And then I can declare, I can call my homepage composable and provide it the state, and fast forward the map, the interactions with the events I want. So for example, when I click on the avatar, maybe I want to call open settings in my view model. And when the user reaches the end of the scroll, maybe I want to call load more content. So this is the mapping phase between my interactions on my view and what I really want to do in my business logic. And the same goes for organisms. So that you want to be generic enough to be used anywhere in your code. So for example, I have a photo picker here, but I want it to be generic enough to be autonomous, because otherwise I will require to define the selection and the update selection mechanism in all my view models. So I don't want that. I want it to be like a black box, something that is autonomous and independent. So to do that, I can expose a public photo picker that is sharing the same structure I showed you earlier, getting the view model, getting the selection, and here calling a stateless composable, internal photo picker. So this internal photo picker is a private function and is a stateless composable. And by separating the responsibility here, first, it reduces the nesting, and secondly, it will help me to do previews, because unfortunately it can be tricky to do composable previews if you are defining your view model in your composable. So in that way, I can decouple the two composable, and I can do my preview on my internal photo picker, which is my final rendering. In the same logic, the compose philosophy is to let the flexibility to the parent to modify the current element. So you should give responsibility to the parent with a modifier. And if you don't do that, your composable will be too rigid to use, and you will not be able to reuse them across your app. So for example, I create here a composable header that is I want its height to be, for example, 56 dps here, but I want also to let the parent modify it how it wants. So here in the homepage composable, I will call my header, but this is the parent that is positioning the header, for example, on the top in the alignment, and fill the max width of the screen, because it has more context on where it should lay out. And you will ask, why not every time? This is one exception I made for myself for this principle. This is when the composable is private. So for... Oh, wow. Qu'est-ce que j'ai fait? Sorry. Thank you. So here I have my public header that is using a private composable, and as this is private, I can fully control the usage of avatar, and I fully control the scope of my function, because it is local to its own file. So here I don't need to necessarily provide a modifier. Last but not least topic, the optimization. So there is a lot to say about optimization in Jetpack Compose. Pardon me, but I will not be exhaustive because of the time and because of my knowledge. When we talk about optimization, it's generally that we want to reduce the unnecessary recomposition. So let's recap the three phases of recomposition. The first phase is the composition. The second phase is the layout phase. And finally, the last stage is the drawing phase. So when something changed in these steps, then it will update it and the one after it. So if something changed in composition, it will re-trigger the phases composition, layout, and draw. If something changed in layout, just layout and draw. And if in draw, just the last phase, which is the less costly phase. So the first phase, composition, is the phase when the tree is constructed. So for example, here I have a composable, and here I can see that given my user property, I modify the tree with my if statement, because avatar is either added to the tree or removed to the tree. So I don't know any modifier that is acting on this phase, because a modifier is kind of an attribute of the element of your tree. So it doesn't have the power to modify the structure itself of the tree. It will not add or remove elements of your tree. So we are safe with modifier on this phase. The layout phase is when each element is placed. So the position, the size, the rotation, the offset. And for example, here I define a size modifier, and that is depending on the variable size. That can be either 48 dps or 0 dps. And at the first composition, the first composition phase is not triggered, but the layout phase is, because size modifier is acting on this phase. Okay, and how do I know that? Because if you check the implementation of size, you will see that it is using an object that is implementing the layout modifier interface. So here, the only phases that will be triggered when size change, it's layout and draw phase. And finally, the draw phase is when each element are drew. So the lines, the colors, the draw behind, the draw on top, the painter for images, for example. And in the same example here, now I use the background modifier, and that is depending on the variable background, that can be either green or red, the color. So when the color will change, it will re-trigger only the draw phase. And how do I know that? Because if I go to the implementation of background modifier, I can see that it is implementing, the draw modifier. So it's a good practice to know the modifier you use, which phases it is impacting. Okay. So you understand that the most costly phase is the first one, because every phases are triggered from this one. So to optimize that, Compose mark every inputs of your Compose function with stable or unstable. So when it is unstable, it means that every part of your code that is using this property will be recomposed every time, whether or not it has changed. Why? Because the compiler cannot guarantee that the property hasn't or has not changed since the last recomposition. Okay? So ideally, you want to provide only stable inputs. You have to know that Compose considers all the primitive type, like string, float, long, string, etc., as stable, and apply the same logic within a data class. Also, you can add the annotation @stable if you can guarantee yourself that the variable will not, the input will not mutate. For example, lot of theory example. I have a model here, data class user, that is inferred as unstable. Why? Because the variable profile picture is mutable with the var keyword. So it is unstable, and then my composable avatar has one input that is inferred as unstable, meaning that each time this composable will be recomposed, then the when statement will be re-triggered, even if my property user.profilePicture hasn't changed at all. So we want to solve that, and we can change the property profile picture to be immutable. So now my user is inferred as stable, and my avatar is now taking an input that is stable, and my when statement is not recomposed each time if my user.profilePicture doesn't change. Also, something to be careful. Any type defined outside of your module is considered as unstable. So let's say I have a domain model class user, but that is defined in another module, then automatically it is considered as unstable despite the two fields are immutable and are declaring primitive type. So what I want to do is to map to a UI state here that is in my module, that is inferred as stable, and then I can use it in my composable avatar that is inferred with the state stable. And this is also a good reason why you should use a UI state and not directly your model in composables. Another important thing about collection stability. So all collections are annotated unstable by default, even if the field itself is immutable. Because behind a field collection, it can be the concrete implementation of collection, can be a mutable list, a mutable set, or whatever. So I have a list of messages here inferred as unstable. So what I want to do is either annotate it with @stable, so I can guarantee that I will never pass something, a mutable collection, to this data class. Or I can use the immutable collection from the package kotlinx.collection.immutable that will do it for me and infer the property as stable. Another optimization to be aware of, you can inline your function when you pass composable lambda. For example, here I define a circled box composable that takes a content that is a lambda, composable lambda. So this will, inlining that, will cause to take the implementation and replace all occurrences of circled box in your code by directly this snippet of code, this implementation. So this will reduce your compiled code, and this is very useful, and your memory impact also. So this is very useful for low-level composable that takes huge composable lambda. So for example, if you check the implementation of box, you will see that it's an inline function because it's generally a low-level composable that takes huge lambda. That's it. Thank you very much for listening to me. And I don't know if I have time for question, but I think it's maybe one or two. One question? Okay. Thank you.
C'est bon ou pas? Oui. Merci beaucoup Vincent. Déjà avant les questions sur l'application, vous avez accès à Open Feedback si vous voulez donner de la win ou des moyens de progresser à Vincent. C'est trop cool en vrai quand on speak qu'après on peut aller regarder ce qu'en ont pensé les participants. Donc faites-le. Et oui, on a le temps pour une question. Et sinon, il y a un coin speaker en bas où vous pouvez retrouver Vincent pour lui poser les autres questions que vous n'aurez pas eu le temps de lui poser. Donc une question au shotgun.
You can ask in English or French.
Regarding stability, unstable and stable, you were speaking about the states, but what about the events? Are they marked as stable or unstable?
Yeah, so good question. So all the higher order functions are marked stable because it will never change across the time because it's always the same reference to the same function. No, it's not quite right because you can have parameters, but it's rare. Most of the time, it never changes. So yes, it is inferred as stable. So whether or not it changes, it's a good. You don't have to be worried about these functions.
Okay, thank you.
Don't hesitate to come and see me, as Marion said, and I wish you to enjoy your conference day. Bye.